Good morning, students. How are you? In previous lecture, we have discussed Biot-Savart law, Ampere circuit law. Today, we will discuss force on a moving charge in a magnetic field. This topic is very important. An electric charge moving in a magnetic field, it experiences a force. That force is known as magnetic force. Consider a charge Q. This is a charge Q moving with velocity V, placed in a uniform magnetic field B. Let theta be the angle between V and B in the direction of B. It found from experiment a force act. This force depend first point F proportional to B, magnetic field, F proportional to magnitude of charge Q, and F proportional to V sin theta. V sin theta. First point, the magnetic force depend, magnetic field, charge and component V sin theta. First equation, this is second and this is third. So F proportional to QVB sin theta and F equal to K QVB sin theta. K is constant, that is 1. So F is equal to QVB sin theta. Now in a vector terms, F is equal to Q V cross B. So the charged particle moves in a magnetic field. It experiences a force that is known as magnetic Lorentz force or magnetic force. Their magnitude is F equal to QVB sin theta. It is clear, this is the magnitude of force. Now, there are three cases. First case, V is equal to 0. Yani F is equal to Q, V, B sin theta. Now, in this case, V is equal to 0. That means F is equal to 0. It means stationary charge does not experience any force in any magnetic field. This is first case. Now second case, theta is equal to 0 or 180. Now theta is equal to 0 or 180, F is equal to 0. Any charged particle moves parallel or anti-parallel. That case, the force will also be 0. Now third case, theta is equal to 90, then F is equal to QVB 90, that is maximum. So their magnitude is F is maximum. Their magnitude is QVB. Now F is equal to QV, the direction of B and V lies in X by plane and F act along Z axis, which is perpendicular to the plane. Yani V and V are perpendicular. V cross V, direction of F. V cross V. It is clear? The direction is given by first Fleming left hand rule and second right hand arm. Now Fleming left hand rule, you see this picture on whiteboard. a left hand, this is your left hand, stretch your left hand in such a way, this is thumb, this is forefinger, this is center finger, in such a way they are mutually perpendicular to each other. Now you see this figure. This figure indicates, this is the center figure, indicates current and velocity, and this figure indicates directional magnetic field, and this figure indicates force. They are mutually perpendicular to each other. Now second, right hand palm rule. Clear? So Fleming left hand rule and right hand palm. Now question is, what is the unit of B? Now F is equal to QVB sin theta. What is B? B is equal to F upon QV F QV sin theta. If Q is equal to 1 coulomb, V is equal to 1 meter per second, theta is equal to 90, then B is equal to F. Yani magnetic field is defined as a force having unit charge moving with unit velocity at right angle to the field. Now what about unit? B equal to, what is force? Newton. What is C? 1 coulomb. What is velocity? 1 meter per second. And theta will be 90. So Newton upon 1 coulomb 1 second, 1 coulomb into 1 meter per second, that is known as 1 Tesla. So Tesla is the unit of magnetic field. This is the force on a moving charge in magnetic field. Now Lorentz force, total Lorentz force, total Lorentz force. Total यानी Lorentz force. When the charged particle moves electric field, inside electric field, that means F is equal to QB. And charged particle moves in magnetic field, that is Fm equal to QVB sin theta. So total force is equal to Fe plus F. So F is equal to QE plus Q, or in vector form V cross B, that is E take common, Q take common and V cross B. This is the total Lorentz force. So charged particle moves electric as well as magnetic fields. So a force exert, that force is known as total Lorentz force. Their magnitude is F is equal to Q E plus Q V cross B. This is the total Lorentz force. Now next topic, force on a current carrying placed in a magnetic field. Next derivation, force on a current carrying placed in a magnetic field. This is a conductor. PQ is a conductor. Suppose this is Y axis, Z axis, X axis, carrying current I. This is force, magnetic field. Consider a conductor PQ. This is a P. Consider a conductor PQ having length L. PQ is an area of cross section, carrying current I. along y-axis, but drift velocity opposite to the current. So force on, or you can say free electron moves. So each free electron exerts a force that is equal to F is equal to E V cross B. Clear? Now total force. So first you calculate total electron present in the conductor. So total electron present in the conductors, that is NaL. A area, L length, that is volume, into N means free electron per unit. So total electron present in the conductor, capital N is equal to NaL. Now total force, that is capital F equal to N small f. Capital N means NaL into E V cross B. IL is a current element. This is IL. IL is a current element. This IL current element opposite to the drift velocity. So that is total force equal to F equal to N E A V D. This is drift velocity V D. N E A V D bracket L cross B. So NEAVD equal to, what is NEAVD? There is some relation between current and drift velocity. I is equal to NEAVD. So that is I L cross B. So that is known as Bill sin theta. This is known as Bill sin theta. This is the force. What is B? Magnetic field. I, current. L, length. Now there are three cases. First case, theta is equal to 0. Then F is equal to 0. Or theta is equal to, second case, theta is equal to 180. F will also 0. Now third case, theta is equal to 90. Theta is equal to 90 means third case theta equal to 90, F equal to maximum. Their magnitude is zero. The direction is given by Flavin left hand rule. Flavin left hand rule means stretch your left hand rule. Stretch your hand, left hand in such a way. These thumb, forefinger, center finger mutually perpendicular to each other represent current, represent magnetic field, represent force. So we have discussed two topics. First, force on a moving charge in a magnetic field, and second, force on a current carrying conductor placed in a magnetic field. So these are the topic, and direction is given by Flavin left hand rule. Okay, thank you very much.